Welcome to the deep dive. Today we're tackling something that's, well, it's everywhere, isn't it? How AI actually learns.
Yes, specifically those big language models, the LLMs.
Exactly. And you've probably seen all the headlines, maybe felt a bit swamped by all the AI talk.
For sure. It's a lot.
So consider this our attempt to cut through some of that noise, maybe make sense of it together.
Sounds good. We're digging into an article called AI Doesn't Think. Here's how it learns and why that's a problem.
Right.
And our goal really is to unpack how these models actually work. Why it's not really thinking like we do.
And what problems that causes.
Exactly. Things like hallucinations, bias,
Yeah.
the tricky stuff.
And the article had this great analogy, didn't it? About the student who just skimmed the notes.
Oh, yeah, that was perfect.
Like they might guess some answers right on the test, but they could also just invent stuff.
Confidently invent stuff. Like the example they gave an AI saying Columbus landed in, what was it, 1800?
Yeah. Completely wrong, but sounds sure of itself.
Yeah.
That really gets to the heart of it.
It does. It shows that gap between just like recognizing word patterns and actually understanding anything.
So let's get into it. How do they learn? You said it's not reasoning.
No, not at all. Fundamentally, it boils down to predicting the next word, or more accurately, the next token.
Okay, tokens. The article mentioned those. They're like word fragments.
Sometimes whole words, sometimes parts, yeah. Like wash and ing in washing. The AI breaks language down into these pieces.
So it's not thinking, I am washing the car.
Nope. It's calculating the probability that the token ing will follow the token wash. It operates on those token probabilities.
Based on all the text it's been trained on.
Exactly. Massive amounts of text. And it does this using weights.
Weights, like little dials.
Kinda. Billions of them. These weights determine how much influence one token has on predicting the next one.
So if it sees capital of France, the weight connecting that to Paris is turned way up.
Precisely. Very high probability based on the training data.
Okay, so it's constantly adjusting these billions of dials. How does it know if it's getting better? If the predictions are good?
Ah, that's the loss function. Think of it like it's internal error checker.
Right.
It makes a prediction, compares it to the actual next token in the training data, and calculates the difference, or loss.
And tries to minimize that loss.
Over and over again, and billions, trillions of times, adjusting the weights, trying to get the predictions closer to what's actually in the data.
So it gets really, really good at mimicking language patterns.
Phenomenally good.
But, crucially, the article stresses it doesn't know that Paris is the capital of France.
Yeah.
It just knows the words fit together statistically.
That's the key distinction. It's pattern matching, not knowledge or understanding.
And that fundamental difference, that's where the problems start.
That's exactly where they stem from. The article highlights a few big ones.
Right, let's talk about those. First up, hallucinations. Sounds pretty dramatic.
It does, yeah. But in AI terms, it means the model confidently generates stuff that's just wrong. False information, made up things.
Like that Columbus example again.
Exactly. Or inventing scientific papers, citing sources that don't exist.
But it's not lying, is it? Like it doesn't know it's wrong.
That's the really tricky part. It's not deception in the human sense. It's just generating text based on patterns it learned, and sometimes those patterns lead to plausible sounding nonsense. It can't tell the difference.
Which sounds dangerous if you rely on it for important stuff.
Absolutely. The article mentions the risks. Imagine AI inventing legal precedents or giving medical advice without any real patient context.
Oof. Yeah, that highlights the need for humans to double-check anything critical.
Non-negotiable, really, especially in high-stakes areas.
Okay, so that's hallucinations. Then there's bias. We hear about AI bias a lot.
Hmm.
How does that creep in?
Well, think about where it learns from. Massive data sets, mostly scraped from the internet, right?
Right. Billions of web pages, books.
And that data reflects, well, us, society, including all our existing biases.
So cultural stereotypes, gender assumptions, political leanings. It's all in the training data.
It's all in there. And the model doesn't have, like, a filter for fairness or truth. It just learns the patterns it sees, biases and all.
So the AI isn't biased on purpose. It's just mirroring the data.
Exactly. The article is clear on that. It's an unintentional consequence of the training data itself.
And it's important to remember, as the article implies, these biases can cut different ways, depending entirely on what specific data was used for training that particular model.
Absolutely. It's data dependent, not some inherent agenda of the AI,
Yeah.
which really raises questions about data curation, doesn't it?
Yeah. Okay, so hallucinations, bias, and the third one was model drift. That was new to me.
Yeah, model drift. It's basically when the AI's knowledge gets stale because the real world has moved on since it was trained.
Right. So, like, an AI trained in 2022 wouldn't know about major events or tech released in 2023 or 2024.
Exactly. Or think about predicting economic trends or consumer behavior. Things change fast. If the model's data stops in, say, mid-2023, its predictions for 2024 might be way off.
Because its knowledge is frozen in time.
Precisely. It's stuck with the patterns from its training data, unless you retrain it.
Which brings us to why these problems, hallucinations, bias, drift, are so hard to fix. The article mentioned cost, right? Retraining cost.
Oh, yeah, huge costs. We're talking serious money and computing power.
It's not like just updating software on your laptop.
Not even close. Training these big models takes specialized hardware, tons of energy, and can run for weeks, even months. It's a massive undertaking.
So that explains why some models, even if they're known to be biased or outdated, might just get retired.
Sometimes, yeah. The cost of retraining or significantly fixing them is just prohibitive for some developers or applications.
Okay, cost is one hurdle. The other big one the article mentioned was the black box problem, opacity.
Right, the black box nature of these models, this is really fundamental.
What does that mean exactly? That we can't see inside?
Sort of. It means that even the creators often can't tell you precisely why the model gave a specific answer.
Really?
Yeah, because the output comes from the interaction of those billions of weights, all adjusted during training in incredibly complex ways. You can't easily point to one weight or one piece of data and say, that's why it hallucinated, or that's the source of that bias.
So you see the input, you see the output, but the process in the middle is murky.
Very murky, and makes it incredibly difficult to debug or make targeted improvements. If you don't know the root cause, how do you fix it reliably?
That lack of transparency seems like a huge challenge for making AI safer.
It really is. It limits our ability to understand, predict, and control their behavior.
Okay, so it's difficult and expensive to fix these things.
Yeah.
But people are trying, right? What are the current approaches? The article mentioned RLHF.
Yes, reinforcement learning from human feedback. That's a major technique being used right now.
How does that work? In simple terms.
Basically, humans rate the AI's outputs. They tell the model, this answer was good, this one was bad, this one was helpful, this one was harmful.
So humans are essentially training it, giving it feedback like a teacher.
Kind of, yeah. Guiding it towards generating responses that humans prefer. Giving it a thumbs up or thumbs down, essentially.
That makes sense. But the article mentioned limitations.
It does. It's very labor-intensive, obviously. You need lots of human reviewers. And you can't possibly review every single potential output, especially for complex or, niche topics. It doesn't scale perfectly.
Right. So beyond humans constantly rating outputs, what else is happening? You mentioned algorithmic innovations.
Yeah, researchers are looking for more fundamental solutions. The article flags a couple of interesting ones. OpenAI's Super Alignment Initiative.
Super alignment, what's the goal there?
The idea is to build AI systems that can actually reason about human values and safety goals themselves, so they need less constant human supervision to stay aligned.
Making the AI understand alignment better.
Sort of, yeah. A more inherent alignment. And then there's Anthropic's constitutional AI.
Constitutional AI. Like giving the AI a rule book.
Pretty much. Training the AI to follow a set of core principles, its constitution, rather than just relying on feedback for specific answers. The aim is more transparency and scalability for safety.
That's a really different approach. Are governments getting involved too? Policy debates.
Definitely. The regulatory landscape is evolving fast. The EU AI Act is a big example the article mentions.
Right, setting rules based on risk.
Exactly. Categorizing AI uses by risk level and putting stricter requirements on high-risk applications, things like safety, transparency, accountability.
And it's not just Europe, is it?
No, there are similar discussions happening globally. US, UK, China, international bodies, everyone's grappling with model transparency, how data is governed, ethical deployment.
And universities are involved?
Oh, hugely. Academic labs are doing critical research on making models more interpretable, finding ways to mitigate bias, developing better tests and benchmarks for AI evaluation. That research feeds into policy and best practices.
So it feels like there's a growing agreement that just making AI powerful isn't enough. It needs to be safe and, well, aligned with us.
Absolutely. It's shifting from just performance metrics to safe, reliable, value-aligned performance. That's becoming central.
Okay, so let's bring this all back home. For you, listening to this, what's the main thing to keep in mind when you encounter these AI tools?
I think the absolute core message from the article is Remember, these LLMs don't know things like we do. They predict, they match patterns.
They lack that deeper understanding of context, meaning consequences.
Precisely. So they can be incredibly useful tools, great for summarizing, drafting text, brainstorming, even coding assistants.
No.
But you absolutely need that human layer of review and judgment, especially when accuracy or reliability really matters. Don't just copy-paste without thinking.
Critical thinking is still required,
Yeah.
maybe more than ever,
Definitely. And the article makes a final, crucial point about responsibility.
which is,
If something goes wrong, if there's an error because you relied on an AI's output, the buck stops with the human user, not the AI.
accountability stays with us.
It has to.
Okay, so let's quickly recap. LLMs learn via pattern matching on vast data, not true thinking. This leads to issues like making things up, hallucinations, reflecting data biases, and becoming outdated, drift.
And fixing these is tough because retraining is expensive and we often can't see exactly why they do what they do, the black box problem.
But efforts like human feedback, RLHF, new alignment techniques like constitutional AI, and regulations like the EU AI Act are all trying to make AI safer.
Still, the key takeaway is human oversight remains vital. Check the AI's work.
Right, and that leads us to a final thought, something maybe to chew on.
Yeah, if these incredibly powerful AI systems achieve their intelligence simply by mimicking patterns in our language, patterns created by humans, what does that really tell us?
Yeah. About human language itself, and about human thought.
Exactly. What does it say about the sheer depth and complexity of actual human understanding, reasoning, and consciousness that these sophisticated pattern mimickers are still just scratching the surface?
And as these systems get woven more and more into our lives, what are the implications of relying on things that mimic understanding without actually possessing it?
That's the big question, isn't it? Something to